Okay, water flows through the screen in the pipe shown in the figure. Determine the loss coefficient for the screen. Alright, so let's jot down some of our givens. We're told we have a velocity of v equals 20 feet per second. Okay. We have a manometer, and the manometer has a fluid which has a specific gravity of 3.2, and there's a differential height in that manometer of 6 inches, okay, which is equal to 6 over 12 feet, which is equal to 0.5 feet. Okay. We're told the fluid going through the pipe is water, and what we want to find is we want to determine the loss coefficient, K sub L. That's going to be the question. Okay. All right, so let's use our mechanical energy equation. We'll have 2 points, location 1 and location 2, strategically placed right above the manometer. Okay. Then we can write down our mechanical energy equation. It says P2 divided by gamma plus, and this would be the gamma of the water, the fluid going through the pipe, plus V2 squared over 2G plus Z2 is equal to P1 over gamma of water plus V1 squared over 2G plus Z1 minus the head loss. Okay. The flow going through the pipe, we're told, is 20 feet per second. There's no area change, so continuity tells us that the velocity has to be the same at locations 1 and 2, so I can get rid of these terms because they'll be equal. There's no change in height between location 1 and 2, so Z1 equals Z2. That will go away, and we'll be left with P2 minus P1 over gamma of water is equal to minus the head loss. Okay, so now we need to try and get some information on P2 minus P1, and we can do that because we have a manometer. So a manometer, if we write down the manometer equation, we'll start at P1. Okay. I notice that the fluid column from here to here is the same as the fluid column from here to here, so that pressure is going to cancel each other out, right? So all I need to do is start at this location. So I'll have P1, then it's going down, right? So I add pressure when I go down. So I add a specific weight of water times the height it went, okay? Then again, the height of this column is going to cancel with the height of this column, and now I'm just going up. Go up, I subtract pressure, so I have to subtract the specific weight of the manometer fluid, which is just equal to the specific gravity times the specific weight of water times the height h, and then that finally gets me back up to P2. Okay. I could rearrange this, and I would have P2 minus P1 divided by the specific weight of water is just equal to, and I'm going to plug in some values here. I'm going to have the specific weight of water, I have the height h, 6 over 12, minus this term, specific gravity, times h, and that is minus 3.2, again over 6 over 12, or 0.5 feet, right? Okay, so this is just going to equal, this is 6 over 12 times 1 minus 3.2. Right, so I notice this term is the same as this term, so I can then substitute this into here, and I have 6 over 12 times 1 minus 3.2 is equal to minus the head loss. Rearrange this, and I'd have the head loss is equal to 6 over 12 times 3.2 minus 1, which is just equal to 1.1. Okay. So now I have what my head loss is, and I'm just left to try and determine what my loss coefficient is. So I know that the head loss is due to the minor component, which is the screen, and that is equal to K sub L times V squared divided by 2G. The head loss I solved for was 1.1. K sub L, the velocity was given to me, that was 20 feet per second. Okay, divided by 2 times G, 32.174. And I could rearrange this and solve for the loss coefficient, and I would see that it was equal to 0.177.